Sir, when do we get PDF, sir?
Of which one are you asking me?
Sir, chemistry worksheet,
Yeah.
sir said about it.
It will be sent to actually DSU. From there you will be getting it. Dayanand Sagar University. From
Yes,
there
sir.
you will all be getting it. Okay.
When do we get it, sir?
Today.
Today, sir.
Yeah.
Thank you, sir.
Hello, good morning, dear students. Today we'll be starting with physics in this session. You already had 2 chemistry classes and then 1 physics, 1 mathematics class. So let's start with some physics as well. Am I audible? Is the board that I have shared visible to all of you? Okay, thank you. Now there's a reason why I have done this. I have basically muted all of you, and also I have not given permission to unmute yourself. Okay, I can do that for a while, check it up. If I found that to be actually a lot of disturbances there, then I'll again disallow that. So I'll see for some time that to allow you to unmute. I have done that now. You can unmute and then answer me whenever you feel that you want to raise a question, or when I ask a question, try to give me an answer, and so on and so forth. Okay. Now the time that is required to actually do a complete crash course program will be much higher. But here we have been given with something like 25 sessions of physics. And in that, I need to actually complete the whole of the syllabus. The whole of the syllabus of the first and the second year is actually a very challenging thing to do. We will try and see what best we can do. So what I will basically look at is to give a little lesser weightage to the first year portions and give more weightage to the second year portions. But today I'm going to start with the first year topic, which you have studied, in fact, perhaps almost 2 years back. Now, the purpose of this course is to basically make you all recollect the ideas that you have done earlier, number 1. Second one, also try and see if you can practice doing the MCQs corresponding to these topics. So our intention behind conducting this course has just been that. And let us be very thankful to Dayanand Sagar University for arranging a free program like this for all of you, and then trying to help you out in preparing for the competitive examination. So with this little remark, 2 participants have raised the hand. Any issues, anything that you want to tell me, please let me know. Shiv Saxena, anything that you want to tell me? Am I audible? Is it okay? Are you all able to? I think those who are basically have become the panelists can unmute and then answer me to the question that I ask you all. Am I audible? Can someone please tell me?
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Is the
Yes,
board
yes.
also visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you so much. So let's actually now begin.
Yes, sir.
Revision would be that I will write down all the important ideas that I feel that you should know in one-dimensional motion. Write it down along with me. I will share these notes with you as a PDF soon after this class with DSU. And then DSU in fact will take the responsibility
Where you will send?
of you there. Okay. So as far as possible, write it down yourself. And also when you write, it's like reading 10 times. So therefore, writing is important. Make a note of it. All this will come to your active memory. And solving the problem becomes easier. All right. Okay. Let's begin if you're all ready with it. So I'll be starting with one-dimensional motion.
Sir, how you will send PDF link?
I'll be sending it to Dayanand Sagar University. They will in turn mail it to you or put it in the WhatsApp group or whatever, or maybe also put it on their website so that you all can download. So they will make some arrangement for sending these PDFs. All right. Okay. Yeah. Let's try and see if you can do all the things in the class and you also write it down. Okay. Don't depend too much on the PDF later on. That's only for standby. Fantastic. So let's start. 1D motion. Are you all ready? Okay. We generally talk
Yes, sir.
position of a particle to begin with. Position, remember, is a vector quantity and will be in general represented by Rx I cap plus Ry j cap plus Rz k cap. Okay, this is what I represent position as a vector. Now, in space, this particular vector may be represented as a point here. So let this be R. Okay. Now it can change the position to R dash and become Rx dash I cap plus Ryj cap and Rz dash k cap. Okay. Then I get, in fact, the position to be changed somewhere here, and R dash is obtained here like this. Again, a vector. Now we define displacement as the change in position. Okay, very simple. Idea is that you should always say it is the final position minus the initial position. That is all, in fact, displacement is about. And in this case, this happens to be simply R dash minus R. Okay, this is the vector, and the displacement is given by the line joining these two. This will be displacement S. So S essentially will be the third side of the triangle. Recollect, triangle law of addition of vectors. So then you will say the third side has to be displacement. As simple as that. Is there a break in my voice? Is it for everyone? Do you all finding that my voice is breaking? Can someone please tell me?
No, sir, no.
No, it is.
So please check the signal at your end. There will be some issues there. Okay.
No, sir. Nothing, sir.
Displacement is the third side of the triangle. Now I look at the next idea, which I call it as the distance traveled. Distance traveled essentially is the path length. Okay. If the particle has come from the initial position to final position, I didn't even bother about its path. It may be a path that it has taken like this to travel from I to F. In that case, the path length essentially defines the distance traveled, and this basically will be a scalar quantity. There will be a lot of confusion about distance traveled and displacement. Okay, so therefore I would like to actually let you know few things in order to clear this confusion. Number one, distance traveled, okay, may not be equal to the magnitude of the displacement. In most of the cases, it is not. Okay, it is generally greater than and only sometimes equal to displacement. Okay, now only case where displacement and distance traveled are equal is in the case of body moving in a straight line. If it moves in a straight line, then the distance will be equal to magnitude of the displacement. In all other cases, distance will be greater than displacement. Okay. Second point to notice, distance will never be equal to 0 or negative for a moving particle. When it starts moving, you can never have distance traveled to be 0. But whereas displacement can be 0, positive or negative. All are possible here. Okay, can be positive, negative, or 0 for a moving particle. That's quite possible. Okay, you can also have negative displacement. I hope you're all very clear about that. Now, these are the points that I always want to actually revise for a concept like distance and displacement. This should be in your summary sheet. Before the examination, go through these points. These are the points that are essentially important for you. Okay. Another point to note here is when displacement is restricted to one direction, then it's called 1D motion. When the S is restricted to a plane, then it's called 2D motion. When there is no restriction, on the movement, it can travel in all the three directions, then it's called 3-dimensional motion. Essentially, 3-dimensional motion has no restriction. In 2D, there is a restriction to be in a plane. In 1D, there is a restriction to be in one direction. All right? Okay. Now, these are the things which are going to help you in answering some of the questions in the MCQs. Therefore, these note. Okay. Before I go on to that, have you all written down this? Can I go to my next page?
Yeah, we are writing, sir. Just a minute.
You're writing. Okay. Okay.
Repeat.
I will be a little slow today. Okay. That doesn't mean that I can be slow in all the classes. It's only until you people get used to my teaching. Let me be a little slow. You can also ask me question, ask me to slow down. But once we gain the pace, I think you all should really come on to this thing, because your time, in fact, is limited. You don't have too much of time. And in between, you also have an English examination to face, right? So we'll be giving you a little break from Monday to complete your English examination. And once that is over, we'll be restarting the classes. But tomorrow you will have class.
Repeat, sir.
Tomorrow there will be class. Tomorrow is a Sunday, but even then we are going to have the class. We will be having the class according to the timetable given to you. Okay, I think most of you have looked at the timetable. Tomorrow we are starting the class at 9 o'clock itself. Make
Okay, sir.
Yeah. Can I go to my next page?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Thank
Yes,
you.
Okay.
yes.
Okay, now let's see. Let's proceed and then go to the second idea here, which will be about velocity. Velocity is generally the rate of change of position or rate of displacement, we call. So velocity by definition is delta x by delta t. Velocity is again a vector which would depend on delta x. So v basically is related to delta x, not necessarily to x. Okay, it is related to delta x vectorially. This is going to be an important point to note. Whenever we say rate, dear students, hereafter, know that we are trying to obtain something with respect to time. I call this as general knowledge in physics. Whenever there's a rate, it has to be always with respect to time. Whenever it is with respect to position, then it's called as gradient. Okay, the changes with respect to space is gradient. Changes with respect to time is called rate. So this is a general understanding that one should have. The unit for this will be meter per second in the SI system of unit. This way of defining the velocity is called average velocity. Similarly, we have one more kind of velocity called as instantaneous velocity. Now, instantaneous velocity will be defined as dx by dt. Okay, so this is in fact the velocity given in terms of instantaneous. Now again, if the velocity is constant, okay, this will happen when acceleration is 0, right? You can then say that the average velocity and the instantaneous velocity will be same only then. Okay, if velocity is varying, is not a constant, then v average will not be equal to V instantaneous. But they both will be related by some expression, but they are not equal, is something that you should always understand. Okay. Another
So,
point here is about the speed of the particle. Speed is always,
excuse me, sir.
yeah.
Sir, can you just tell me, like, when do we write for the dx by dt and delta x by dt? Like, what's the difference?
Difference is the following. In case of average velocity, you are measuring with larger time interval. Let us say that you will try to find out the velocity by measuring the displacement over 10 seconds. Then you have some displacement divided by 10 seconds. That's the average velocity over 10 seconds. But if you want to find out what is the velocity at 0.1 second, okay, 0.1 second,
Okay, sir.
then you will be trying to obtain the velocity at that 0.1 second, then it becomes instantaneous velocity. It's done with a shorter time interval. Mathematically speaking, delta t should tend to 0, should become as small as possible. Physically speaking, it will be very small when compared to the travel that the particle basically has. Let us say it has done 10 hours of travel, then 1 second will become small enough to be considered as instantaneous. If the particle has traveled only 1 second, then 0.001 second will be considered to be instantaneous. All right. So the delta t tending to 0 physically has a meaning of this kind. Am I clear? Did I clear it out?
Yes, sir. Yes.
Now the speed is something which is related to distance. It is distance traveled divided by time taken. By time taken. You will find that the speed, magnitude of the speed will be always greater than or equal to the magnitude of the average velocity, will be always greater or sometimes equal. Okay, that happens very rarely when it becomes equal, but most of the time it is greater. Please remember that they both are not same. But a point to note here is the instantaneous speed will be equal to the magnitude of the instantaneous velocity. For velocity, both of them will be same. Okay, magnitude of the velocity and the speed are going to remain the same. All right. This is a question that I had found to have come in fact, few years back in the CET. So please make a note of this. These are the finer point that you need to note in a class like this. I hope I made that clear to all of you. If you all have written down this, I want to go to my next page.
So can you explain it again, sir?
The instantaneous speed is always equal to the instantaneous velocity. The reason is, if you consider a particle moving and then it has a xt graph like this, then instantaneous velocity at a point is always obtained by drawing a tangent to it, right? Now I'll make this as dx and this is your dt. Sorry, dt and so you will be measuring dx to be a very, very small one. So dx is very small, where there is no change in direction or magnitude. Okay, and thereby I can
do we
say
have to write
the
mod?
velocity and the instantaneous speed has to be same because it doesn't change the direction, and hence there is no change in direction. Let us say change in direction, and hence I can say that delta dx, since it's very small, instantaneous speed will be equal to the magnitude of the instantaneous velocity. Okay.
So do we have to write mod, sir, for the instantaneous velocity?
Mod, because the magnitude of velocity is what is always comparable with speed.
Okay.
Not with direction. Direction has not got nothing to do with speed, isn't it? Okay. Now let me move on to my next point here to be worried about. I want to spend a little time in the determination of average velocity. Okay, I want to tell you a few things about this average velocity. What is it about? Let me consider some 3 cases of importance which keeps coming in your examination. The first one is, let's say that a particle goes from A to B. Okay, A to B, point A to point B, 2 stations, a car is moving, let us say. Now, in the first part of the journey, it has a displacement of S1 and the velocity V1. And in the second part of the journey, it has a displacement S2 and velocity V2. Now, the velocity V1 and V2 are constants in their intervals. But what will be the average velocity over the journey for the entire journey AB? Then I can say that the average velocity here will be equal to the net displacement divided by the time taken, S1 by V1 plus S2 by V2. So this will be the expression for the average velocity. Note an important point here. If velocities are same, okay, sorry, I should say if the displacements are same over these two, I can have as a particular case centered S1 and S2 being equal to S, then the average velocity will be written as 2V1 V2 by V1 plus V2. It's just this expression being written down this way. Will be very useful for solving problems quickly. So make a note of this here. The same way, if you have large number of intervals, you can say that the general expression for the average velocity in this case will be summation of all the displacements divided by summation of all the time intervals S1 by V1. Okay, this is the general expression for many small displacement, and you finally find this average velocity. All right. Case 2, very important. Again, lot of times these questions come, so I am trying to therefore preempt by giving you all this beforehand. Now there are 2 intervals of time which is known to me, okay, over which the velocities are given to be V1 and V2. Here, the information that I have with respect to time. Earlier, I had the information with respect to displacement. Okay, then how do I find the average velocity in this case? The average velocity will be the total displacement V1 T1 plus V2 T2 divided by V1 plus V2. Okay, I will not have time to derive all this, nor is it necessary at this stage. If you know the relation, I think it should be good enough. Note number one, if T1 and T2 intervals are same, okay, but the velocities are still different, then what will be the average velocity? That will turn out to be simply V1 plus V2 divided by 2. So the average velocity in such a case is simply the average of the 2 velocities. Very easy to obtain. And then if you have large number of such intervals being given to you, as a general expression, I can write this as summation of VI divided by summation of, yeah, I think I made a mistake here. It's
T1 plus T2.
And T2. T1 and T2. So summation of all Ti's. Good. I have very attentive students. I'm very happy about it. So it's sum of T1 and T2 in the denominator. Thank you very much. It was just an oversight that I wrote it down that way. I again go back to that and tell you it is V1 T1 plus V2 T2 divided by T1 plus T2. Priyanshu Verma, any problem? Anything that you want to ask me? Okay. If you all have written down this, I want to go to my next page and next idea. Can I?
Yes, sir.
Thank you. Is my speed all right? Do you all basically getting used to this idea?
Yes, sir.
Yes, sir. Yes,
Okay.
sir.
Are you able to
Yes, sir.
what has been written down on the board?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, thank you. Yeah, thank you so much for trying to be interactive and then giving me the inputs. Let's go to the fifth one. I think chat is something which we'll use only as a last standby. If you keep chatting, I can't go to that and then look at it. So those of you who are basically allowed to speak can speak and tell me what your issues are. Next part that I have to look at is about the acceleration. Okay. Now, in case of acceleration, it is defined as the rate of change of velocity. Physics people are extremely consistent. We define in a particular manner. When we say rate of change of velocity, we mean that acceleration is essentially delta V by delta T. All right. And I call this as the average acceleration. Now, whenever it comes to instantaneous acceleration, then I'm going to define it by dv by dt. Look at it. Yeah. So instantaneous is always this. Average is over a larger time intervals. Instantaneous is for a very small interval of time where delta t will tend to 0. So I have to find out this instantaneous acceleration. Okay. Now, very important to note here. Acceleration is always related to change in velocity. Okay, not just to velocity, but in change with the change in velocity. Now, when we say acceleration is 0, then we mean delta V is 0, but V need not be 0. Okay, it can be a constant. Even then, the acceleration will become 0. There are plenty of examples where this happens, where the acceleration is 0, but velocity is not 0. We'll take up some examples for that. Okay. And in the same way, I can also
Explain once more.
Velocity to be 0, but acceleration need not be 0, because you have a possibility that the change in velocity need not be 0. All right. And therefore, very important idea, dear students, velocity is 0, but acceleration need not be 0. You can have many examples for that as well. Now, there are also possibilities that the acceleration in many cases can be perpendicular to velocity as well. And you should know the cases where this happens. So let us take up some examples here. And the example that I want to take up in this case is your SHM. You all have studied this in your first year. If you look at an SHM, there are positions marked here called as the mean position, the extreme positions. All right. Now, at the mean position, you will say that acceleration is 0, but velocity is not 0, right? And at the end point, you will find that the velocity will be 0, but acceleration will not be 0. Both the cases being taken care of here, isn't it? So, where do you find acceleration to be perpendicular to velocity is in the circular motion. If you have a particle moving in a circle, if it has a velocity v here, then the acceleration will be perpendicular to velocity like this, towards the center. V is tangential, acceleration is towards the center, which is radial. And hence, you will have this to be perpendicular. In fact, A and V can make any angle between them. Any angle between them. I will take up two special cases there. If A and V are in same direction, then it's called accelerated motion. If A and V are in opposite direction, then it is called decelerated motion. Okay, decelerated motion. So in In the first case, velocity keeps on increasing. In the second case, velocity keeps on decreasing. Okay. This is what I wanted to tell you about acceleration. If you all have written it down, I want to go to my next page.
Sir, can you please explain once again?
Which one?
Sir, first point.
Acceleration is always related to change in velocity. Okay, not just to velocity. If you just know velocity at one point, you can never find out acceleration. You can find only if you know acceleration at velocities at 2 points. Then you can say v2 minus v1 divided by t will give you the acceleration, isn't it? So you can't find out only with one single value of velocity. That is what I wanted to tell you, is related to change in velocity, that is delta v. Okay. Now, there are several cases where acceleration is 0, but velocity is not 0. There are cases where velocity is 0, but acceleration is not 0. I took the example of HHM to illustrate these 2 points. Did you understand that? At the mean position, acceleration is 0, but velocity is not 0, isn't it? So this is this particular case. Yeah?
Yes, sir.
In the extreme point, velocity is 0, but acceleration is not. So this corresponds to your second. Am I clear?
Yes, sir.
The girl who asked me this, can I go to my
Yes,
next
sir.
slide then?
Yes, sir.
Okay, thank you. You can stop me at any time like this and ask me questions. No issue at all until the number becomes too big. Okay. Can I go to my next page?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, good. If you find me fast, please tell me. Is my speed all right? Am I okay?
Yes, sir. You're fine.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Now let us go to equations of motion, which is derived for a condition that acceleration is constant. Remember, a can be plus or minus a naught. It can even be minus. For both the cases, you will have the expression for the displacement, velocity, and so on and so forth. What are the equations that we have? V is equal to u plus at. Okay. Then we have S is equal to ut plus half a t square. Look, I am putting arrow for all of them. They're all vectors, mind you. Many of us will go wrong by not taking it as a vector. So please take this as a vector. Then the other one is v square is equal to u square plus 2 a dot s. Don't forget this. It's a dot product between acceleration and displacement. This particular question was there few years back. This itself, whether it's a dot s or simply as. Okay. So important ideas. In one-dimensional motion will not matter, but in two-dimensional motion, all this will matter. Last one is the displacement in the nth second, which is equal to u plus a by 2 into 2n minus 1. This is called displacement in the nth second. In the nth second. Okay. Now, very simple. You all know about this equation, and it's important for us to also look at the problem types, which we'll do later. But certain points to note. Okay. All are vector equations. Be careful about them. Okay. We can caution yourself when you're using, be careful about them. Yes is displacement and not distance. I'm specifically telling you this, and not distance. Okay, we don't have any expression for distance traveled. It has to be done case by case. It can't be generalized and written an equation like this. Okay, so please be careful about it. Third one, SNS the displacement in nth second. Now, some of us will have confusion about what this nth second mean. Okay, let me tell you what that nth second mean. If a particle has started from O and has started traveling along X, then we'll find that it would have traveled a certain distance after 1 second. It would have traveled a certain distance after 2 seconds, after 3 seconds, a certain distance, and so on and so forth. But 0 to 1 is called first second. 1 to 2 is called the second second. 2 to 3 is called third second, and so on and so forth. And nth second will correspond to n minus 1 to n second. So please take it to your system. There's n minus 1 second to n second is called as the nth second. It's called as the nth second. All right. Whatever I wanted to tell you about the 1D motion, I think I have told you by now.
Some disturbance.
Which one?
Excuse me, sir. There's some disturbance.
Oh, there is some disturbance, is it?
Yes, sir. There is some disturbance.
Disturbance caused by whom?
I think someone's mic is on. There's some
Someone's
voice
mic
from
is
the
on.
mic.
So therefore, I'm going to take away your rights of your mics then, shall I?
Yes, sir. You mute everyone.
If I do that, then there will be no interaction in the class, I say. I want that, but I want you all to be a little more responsible. You will be, isn't it? You're all, in fact, good students. Be a little more responsible. Only when you want to ask a question, raise a doubt, switch on the mic. Otherwise, please switch off the mic. I don't want to take away that right from you. It's too draconian. Okay, I will do it if it is inevitable. Can I go to my next page if you're all okay with this?
Yes, sir. Yes, sir.
Yes, sir. 1 minute, sir.
Okay, sir.
No. Can I go to my next page?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you.
Sir.
Okay. Now,
Excuse me, sir.
yes, sir. Yeah.
Why should it be only displacement but not distance?
Yes. Because I told you that all these equations are vector equations, right? I've
Yes, sir.
defined yes with respect to velocity, acceleration, they're all vectors. And therefore, the quantity on one side is vector, other side can't be a scalar. Even that has to be a vector. And therefore, it has to be displacement and not distance. By the way, it's always easier to find the displacement because it only depends on the initial and the final position. Distance will depend on the path taken by the particle. So it has to be looked at how the particle has traveled from one point to another. Okay. Therefore, distance travel is always difficult to obtain. Displacement is very easy to obtain. Did that
Okay, sir.
point make it clear to you?
Okay, sir.
Okay. Thank you. Okay.
Thank you, sir.
Now let us look at problem types that you can get in 1D motion. I think this is something very important, I would say. The first type of problem can be on displacement, distance, travel, and so on and so forth. Okay, I will not take a specific example for this, but just tell you that this displacement has to be obtained by writing down the final position minus the initial position. Okay, but distance traveled is always the path taken by the particle. So path length becomes important. And one example that is very, very favorite to teachers is this. Let's say that particle is basically moving from point A to point B. Okay, it has traveled like this, in this way. It has taken this path. If the radius is R if the radius is r, then you will immediately say that displacement essentially is equal to 2r, final minus initial. If you take just 0, this will be equal to 2r, and then this 2r minus 0, you get this to be 2r. Okay, towards right. Towards right. It's a vector quantity, so therefore I should tell you the direction. But if you look for the distance traveled, then you have to take the path length of this. What is the path length that it has traveled is half the circumference, which therefore should be equal to pi r. Here you don't have to specifically say anything about direction. So distance traveled will be equal to pi r, whereas the displacement will be equal to 2r. Okay, there can be questions on this itself. Average velocity, I have already mentioned to you what are the different types of problems that you can get. Okay, now let me look at the second type of question that you can get. You can get questions on equations of motion. All the equations can be combined together and be asked questions. So I just want to take one example here, which will also be a big lesson for the entire physics class. And therefore, I want to take up this example and solve it for you. Are you all ready to solve a problem?
Yes, sir.
Yes, sir.
Yes, sir.
A particle has a displacement of 46 meters in 2 seconds. In 2 seconds, and it has a displacement of 128 meters in the next 4 seconds. Look, students, we will not have time to write down the full sentence of the problem. I will only mention the problem like this. Should be complete. Information is there. Particle has traveled 46 meters in first 2 seconds and has traveled 128 meters in the next 4 seconds. Next 4 seconds. The question is find acceleration and the initial velocity of the particle. Okay. Now there are 2 unknowns in this question. If there are 2 unknowns, you'll have to set up 2 equations. This is something as a lesson for all of you. Moment you say that there are some number of unknowns, you'll have to set up so many number of equations. So you should keep searching for those equations quickly, set it up and start solving them. Okay. And this is a problem of 2 unknowns and I need to set up 2 equations. Now, where do I get those equations from? Let us see. Now I say that displacement is 46 meters in 2 seconds. So I can say that 46 should be equal to 2u plus half a into 2 square. So this would turn out to be 46 equal to 2u plus 2a, or I can say that a plus u should be equal to 23. Equation number 1. Simple. A plus u is equal to 23. Equation number 1. But there are 2 unknowns. I can't solve this to get a or u. Both not possible. That is why second data is given to us. What does that say? It says 128 meters in next 4 seconds. And therefore, I would say in a total of 6 seconds, it has traveled a displacement. It has a travel displacement of 128 plus 46. All right, 128 plus 46, and you will now get an equation. Okay, let us see what that equation is. What will this be? 128 plus 46. How do you do it? Will be equal to 174. Am I right? 174. Now I will say that this 174 should be equal to 6u plus half a into 6 square. That will be 174 is equal to 6u plus 18. 36 divided by 2 is 18a. Equation 2. If you're smart enough, you will say that this equation also will simplify, not a big issue at all. This will simplify and give you a very easier one. U plus 3a will be equal to 29. will be equal to 29. Let me take this as second equation. Now solve these two simultaneously. You all, it seems, a very good students of mathematics. That's what Sherry sir told me yesterday. So since you are good students of mathematics, you can solve this simultaneously to get A and U very quickly. Let's see how quickly you can do it. I will also do it in the meantime. Okay, I will do 2 minus 1, and then I'll end up getting 2A is equal to 6.
A is 3
So
meter
A
per
should
second
be
square.
A is 3.
meter per second square.
U is
Okay.
20.
Once I get A, then I get 3 plus U
is
is equal
20.
to 23.
U is
and
20.
therefore U should be equal to 20 meter per second. Isn't it interesting? Yeah. Isn't it interesting? So I found out A, I found out U with the two data that is given to me. Wonderful. Because many of you are giving me answers to this. Very glad. I'm so happy and thrilled by looking at that. Can I go to my next type of problem?
Yes, sir.
Okay, very nice. So since you're all ready for the next type of problem, let me take you to that. Now I'm going to my third type of problem. Am I right? Third type of problem. This problem will be on graphs. Will be on graphs. You will be looking at position time graph, velocity time graph, and acceleration time graph. The three kinds of graph that are very commonly used. I'll take a few cases and try to illustrate what these are going to be. Case 1. Let us say that acceleration is 0. Acceleration is 0. Then I get velocity to be constant. In such a case, how will the xt graph look like? It will be a straight line. Now, what does the slope of a xt graph always give you? The slope gives you velocity. Same way, if I plot velocity versus time graph, I'll be getting, in fact, a line which is parallel to t-axis, showing you that the slope here is 0, and therefore acceleration also is 0. AT graph is the simplest. AT graph is the simplest. You will have acceleration to be represented along the t-axis itself, because acceleration is 0. Okay. Now, maybe at this point itself, I can tell you, if you try to measure the area under the curve or area under this will give you the displacement of the particle. Gives you displacement of the particle. Okay. Let me go to case 2. In case 2, I will say that acceleration is constant, but positive. Okay. In that case, how do I deal with a problem here? How do I obtain the graphs of all the things? Okay. I can say that here you may have the equation to be equal to x is equal to ut plus half a t square, and hence it's going to be a parabolic like this. And here, at any point in time, if you measure the slope, then it gives you velocity at this point. And look, velocity is different at different points. So you will have velocity to be different here. V dash will be greater than V. As the time progresses, the velocity also keeps increasing, or the slope also keeps increasing. But one point that I want to make, I will let you know about it now.
Okay,
Please
sir.
remember, the path taken by the particle is not this curve. It is along this line. So the curve here doesn't show you the trajectory of the particle. Doesn't. Okay. Next one is V versus T. The equation will be 2 plus AT. So you will get actually a straight line here like this. Okay. Again, the area under this will give you displacement. Slope of this will give you acceleration. VT graph therefore is very important. We'll be referring to this in the problems also later on. That going to be an important part. Lot of questions come on that. Now AT graph will be simply a straight line in the first quadrant, okay, parallel to t-axis. Case number 3. Let us take acceleration to be constant, but negative. In that case, how does xt graph look like? I would have loved to see your graphs if you have written it down, but I don't think we'll have provisions for that. So if you draw an xt graph, the graph would basically look like this. Okay, if you plot acceleration to be negative. So there is a particular point at which the slope becomes 0. Okay, which means velocity would become 0. That is the highest point or the maximum displacement that the particle can have. So if you are asked to find out the maximum displacement of a particle, look where the velocity becomes 0. That is the point where the displacement becomes maximum. It's an important lesson. Will you all note here that x is maximum when velocity momentarily becomes 0. Okay, when velocity momentarily becomes 0. How does a VT graph look like? You initially start with some initial velocity, and then the velocity keeps on decreasing because it's a decelerated motion, and then it just continues here like this. Okay, now this part of the displacement here will still be positive. All these can come as questions. Okay, so therefore write down this in your summary sheet. Will be very helpful during the examination. Okay, just before the examination, go through this. This is going to help you a lot. This part, displacement will be negative. Displacement will be negative. This part, yes, is positive. This part, yes, is negative. Okay, can I go to my acceleration time graph then, if you all have done with this?
Yes, sir.
Okay,
Yes,
I'm
sir.
just keeping it here. But meantime,
Yes,
let
sir.
me write down
Can I scroll it a bit up?
AT graph. You will have AT graph to be obtained like this, minus A. This will be the graph that you have for AT graph. Very simple. AT graphs are the simplest that you can have. Shall I go to my next part? If you all are done with?
Yes, sir.
Thank you.
Yes.
I'm going to the next page, hoping that all of you have written down this. Okay. Now, let us basically look at few, again, problems that can come on this graph itself. Okay. One of the important points to be noted in the graph is you have to basically obtain displacement and acceleration from a VT graph. I think I told you about that already. The second case would be the conversion of graphs from one type to another. Let us say that I give you a VT graph and then ask you to convert that to an XT graph. A graph like this, where initially the velocity increases, attains a maximum, and then decreases. Now convert this to an XT graph. An XT graph. How would an XT graph look like? The XT graph for this particular case would look like, initially it's accelerating. A is positive. So look how we had got for A positive. We had got it like this. This will happen, let us say, up to a time interval T0. Okay. Then this will be accelerated up to T0. After T0, this will start decelerating. Then it has to go like this. Okay. Look at the kind of curve that I get for a XT graph or VT graph drawn here like this. Very important. Third one. Third kind of question that can come here is,
can you explain it again, sir?
Graph for a given situation. Yes, sir. Any question? For a given situation, like I'll throw a ball up with velocity u, then it reaches the ground. Now draw an XT graph, VT graph for this purpose. Okay, how does an XT graph look like? Very simple, dear students. XT graph would be simply this. Okay, then how does VT graph look like? It starts off with some velocity u0, so it has to start from here, and after that it's just the deceleration. So this is the point where velocity is becoming 0. This is the maximum displacement point, maximum height. After that it reverses its direction and then simply keeps going down the same straight line. Okay, this is where the velocity would become 0, maximum height attained. So this is how I get. But whereas the AT graph will always be minus g. Will always be minus g. All right. So AT graph is just given by this. Okay. So I think I have basically looked at this particular one. Second case. Let us draw a ball from height and then it rebounds. Can we write down all the three graphs for this case? How does an XT graph look like? You are dropping from a height, so you have to start from h. Then initially there will be acceleration downward, so this is the curve that I get. Once it rebounds back, then it's going to be like this. Okay. But what is very interesting in this case is the velocity time graph. In the velocity time graph, start from v equals 0 because you're dropping from a height. Then velocity will be negative for some time until it hits the ground. The moment it hits the ground, it rebounds back to this point, and then the velocity will basically become reverse. It becomes positive, and then it again starts decreasing like this. So this will be the VT graph for this particular case. AT is similar, is just minus g in this case. Are you all done with? Can I go to my next point?
Yes, sir.
Yes, sir.
Yeah. Write it down. Take your time, but not much also. Some of you have been raising your hand. I really don't know why always minus g. That's a good question. I will clarify that down. Arya Gowda, is the same question? I have a doubt. In a AT graph, object moving with variable acceleration. Yeah. How do I plot a graph with variable acceleration? We'll take it up as a next time. Yes. We'll take it up as a next time. Is it all right? Can I go on to my next page, or should I wait for some more time?
You can go, sir.
You can go, sir.
Thank you.
Sir.
Yeah. Can I?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Sir.
sir.
Thank you. Thank you so much. You all have been wonderful students. I'm really, really happy about that.
Thank you, sir.
You're welcome.
Teacher also, sir.
Huh? I'm sorry?
Wonderful teacher also, sir.
Okay. Now, the next type of problem is essentially motion under gravity. Motion under gravity. Now, how do we deal with this particular case? I would say that take acceleration always be equal to minus g. Question is why? Mother Earth is always pulling the object towards itself. In what direction? In vertically downward direction. Since downward is negative, you will find that taking A as minus G is a big advantage. Some of the books may give you take a minus G when it's going up and plus G when it's coming down. But believe me, this is more easier than that. Okay, take A to be negative, then this is going to be always easier. Okay, I will illustrate that with an example. Take A as always minus G. Let us say that I'm standing on the top of a tower and then throw this ball with a velocity of 20 meters per second in this direction, such that the ball will go up and fall to the ground. Fall to the ground here like this. Yeah. Now, if the height of the tower is 100 meter, find the time taken for this journey. Now, if you go by your textbooks, it will tell you to find out T1 here first, then T2 here, and then find the total time to be T1 plus T2. But I will tell you, if you take A is equal to minus G, equal to, of course, minus 10 meters per second square, then you can solve this problem in one shot. Okay, I'll teach you how to do that. You can very quickly solve this problem. Here, the displacement is given to be, okay, 0 minus 100, because my final point is here, my initial point is here. I told you for displacement, it doesn't matter how the particle traveled. Only the final point matters. So it's 0 minus 100 is equal to minus 100 meters. And also, displacement is downward, and therefore S has to be negative in this case. Initial velocity is 20 meters per second. Acceleration is minus 10 meters per second square. So I'll get an equation which is equal to minus 100 is equal to 20t minus half 10t square. I used S is equal to ut plus half a t square. So what did I end up therefore getting is 5t square minus 4t, sorry, t square minus 4t minus 20 is equal to 0. I hope I'm okay with this. Okay. Think about it. This is 5. Then I took divided that in by 5. Then I get this to be t square minus 40 and then minus 20 is equal to 0. This is a quadratic equation. Solve this quadratic equation and get the problem done. So if you solve this quadratic equation, what you will end up getting is, okay, t is equal to 4 plus or minus root of 16 divided by 2. So you simplify this further, you get this to be 2 plus or minus 2 root 6. So therefore, time should be equal to 2 plus 2 root 6. 2 root 6. Take only plus, forget about minus. Okay, only plus is to be taken. Minus if you take, time becomes negative, has no meaning. So therefore, should be. That is why I always consider A to be minus G. Take A to be minus G, it's a big advantage. Are you all okay with this, students?
Yes, sir.
Yes, sir.
Can I go to my next page? Are you all still ready?
Just a minute, sir.
Just a minute, sir.
Just a minute. Okay. I keep pushing so that I can also start solving MCQs after this.
Sir, can you teach the other way, sir?
What message is that?
Can you teach the sum as the other way, sir? As you said, we can use T1 and T2, sir.
I'm sorry?
Can you do the sum in other way, sir?
What way?
You had said that apart from a is equal to minus b, sir.
You can do it, but I don't want to do that because it's going to take a longer time.
Okay.
Fine. So now, can I go to my next idea? Is it all right? Are you all done with?
Yes, sir.
Yes, sir.
Yes, sir.
Now someone asked me about variable acceleration. What do I do with this? Someone also asked me, are we not solving MCQs? We will solve, I say, but before that you should know what are the important ideas. No. What do you all feel? Should I do this or go to MCQ directly?
No, sir. This is directly.
Thank you. Now variable acceleration. Whenever you have variable acceleration, then how do I deal with this? Number one, equations of motion not valid. Not valid. Okay. Now, if I know x, if I want to find out velocity, then I have to find velocity by differentiating dx by dt. Okay, so velocity will be equal to dx by dt. If I know velocity, if I want to find out acceleration, then I have to find out acceleration by differentiating velocity with respect to time. That is the only way of doing it, dv by dt. Then if I know acceleration and I want to find velocity, then the only way of doing this is velocity should be written as integral a dt. You're all good students of mathematics, so you will know how to find integration, right? So integral a dt.
Yes, sir.
Similarly, if you know velocity and you want to find out x, then x will be written as integral v dt. Integral v dt. So this is the way of working out the problems here. Let us take one example quickly and then do it off, so that someone asked me for variable acceleration and therefore I'm keen in telling you about this. Let's say that acceleration is given to be 2t plus 4t square. All right, this is what is acceleration given by. It's a variable one, it's varying with respect to time. Okay. How does the graph look like with time? The graph is going to look like this. Okay, it's a parabolic one equation, and therefore it's going to look like this for a variable acceleration. How do
can you explain it again, sir?
I can find velocity by integrating acceleration with respect to time. So that will be 2t plus 4t square dt. Then I'll be getting this as v is equal to 2t square by 2 plus 4t cube by 3. Don't forget to add integration constant. Okay, so the expression for velocity is given by this. Finally, if I want to find out x, it should be integral of v dt. That would be integral of t square plus 4 by 3 t cube into dt. Okay, don't ask me to plot velocity and x in terms of time. I say it's going to be tough, so I'm not going to do that now. So x therefore will be equal to t cube by 3 plus this becomes 4 e to the power 4 by 3 into 4, and I'm going to therefore get something like this here, t cube by 3 plus t to the power 4 by 3. Don't forget again to add the integration constant.
So can you explain it again, sir?
Which one?
No.
Can you explain this page again?
Okay. I want to find out how to find out velocity if the acceleration is given to me. So velocity will be integral of a dt, acceleration into dt. Expression for acceleration is given to you here. Put that in. 2t plus 4t square into dt. You all know how to do integration, isn't it?
Yes, sir.
Yes, sir.
Okay. Now
Yes,
integral
sir.
of
Yes, sir.
Yes, sir.
t square by 2. Integral of 4t square becomes 4t cubed by 3 plus c. So I get the expression therefore for the velocity like this. 2 can cancel off, so you have t square plus 4 by 3 t cube. Now if you want to find out x, it's v dt and do it like this. So since you wanted me to actually explain this, I have basically written down this part. All right. Okay. One last part I just want to mention, and then after that we'll start solving MCQs. Don't worry. If there's a spillover, we will do the MCQs also in the next class, tomorrow's class. But let us not hurry up. Let us try to actually recollect all the important ideas in this chapter. Can I go to my next page then?
Okay, sir.
Okay, sir.
Yes, sir.
Yes, sir.
What happened?
Nothing, sir.
Next is about the relative velocity. Is about the relative velocity. What is the idea of this? You will find that relative motion, I would say, velocity is actually a particular term. Motion is a better term. Okay, is given to be relative motion. Then what does it mean? You will find that the relative position of a particle with respect to another particle will always be written as RA minus RB. Okay, if I have a particle given here like this is R B and this is RA, then position of A with respect to B will be given RA minus RB. Similarly, velocity of A with respect to B will be given as VA minus VB. Okay, then velocity of acceleration also will have a similar expression, VA minus VB. Now, if you have all the terms in terms of relative, you can use the equations of motion for a relative frame. That is, I can write down SAB to be equal to UAB T plus half AAB T square. This is a valid equation. This is a valid equation. It becomes very simple in certain cases to find out things in a relative frame. Same way, VAB. Switch off your mic. UAB plus AAB T. So this will be again a valid equation. We are going to use this as an advantage while solving problems. Okay.
Can you explain it again, sir?
Advantage while solving problems. With this idea, I am now going to solve MCQs. Are you all okay with this? Can I start MCQs?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
The questions you will be getting it after this. After the class, I will send the questions. But for
Okay,
the
sir.
Okay, sir.
Okay, sir.
Okay, sir.
displayed on the board like this. Okay. A ball is dropped from a height, reaches the same height after elastic impact with a glass floor. If the event is continued, the velocity time graph take downward direction as positive. That's important. Okay. Take downward direction as positive. Usually we take downward as negative, but here they're asking you take the downward direction as positive. Students, this is important. In the question, they are going to change the certain conditions. They are going to make the problem a little more difficult and then do it. If it were to be downward is to be negative, then you all know how to solve this problem. Okay, if you take downward to be negative, I have done this problem for you just now. A ball drop would actually look like this, right? Would look like this. But what is the question here? Take the direction as positive. So downward is taken as positive in this case. In such a case, you should get whatever graph that I get here, ulta of that, reverse of that. And therefore, the third one is the right option. So you will have initially velocity to be positive because downward is positive now. So hence, I get this curve to be obtained. One after the other, there's a rebound. So it keeps on doing this. Okay. Very interesting, isn't it? So the first question quite easily answered because we have already discussed most of it. Okay, that is what in fact quickness is going to be. If you know, if you're familiar with the idea, then the questions can be very easily done. For a moving body at any instant of time, if a body is not moving, acceleration is necessarily zero. What is your thoughts on it? Body is not moving, acceleration is necessarily zero.
False.
Correct? Because you can't have momentum in a body to be at rest. Velocity is zero. Rest means that. Okay? Is not moving. Momentarily zero, but acceleration need not be zero. So acceleration is not. If body is slowing, the retardation is negative. Body is slowing, the retardation is negative. No, retardation is positive. Retardation itself means negative. Negative of negative would give you positive, isn't it? And therefore not the right one. If body is slowing, the distance is negative, not necessarily.
False. False, sir.
Will never be negative, isn't it? So such a
Yes,
wrong
sir.
statement, look at it. Fourth one, if displacement, velocity and acceleration at that instant are known, we can find the displacement at any given time in future. Yes, if the same conditions continue, you can do that. And hence I would say fourth one is an appropriate answer to our question. Fantastic, I say. Two questions quite easily done. Let us see what is happening to the third one. A body is dropped vertically from a height d above the ground. It hits the ground and bounces up vertically to a height d by 2. Remember, d by 2. Neglecting subsequent motion and air resistance, its velocity v varies with the height h above the ground as. Wonderful question. How does velocity always vary? V square will be equal to 2gh or 2gy, isn't it? That's how the equation is. Velocity and height, not time, velocity and height. Now, this is basically an equation which gives you something like y square is equal to ax. Remember, you will get a parabola, but that parabola will be about x-axis, not about the y-axis. So this can't be the one. Okay, this can't be the one. And a straight line can never be because it's v square. So even third one cannot be. So I eliminated the answers easily than answering the question. Okay, but that doesn't matter at all in MCQ. If you can eliminate the three of them, remember you've got your fourth one. That's smartness. You can now try to understand how this is correct.
So can you explain the question again?
Look at it.
No.
V is equal to root 2gh, isn't it? So as the distance, this drop from a height h, as the distance decreases, velocity will become more and more negative. When body is coming down, it is becoming more and more negative. When it hits the ground, it will have a velocity v0. But when it comes to this, it will not have the same velocity because during the collision, it has lots of energy. So its velocity will be lesser. But it has changed its direction. From negative, it has become positive. This happens because of collision. And after that, it slowly rises up and then reaches the point d by 2. Very interesting problem. And therefore, option 1 is the correct one. Am I clear? Is it okay?
Yes, sir.
Yes, sir.
Solving the problem.
Yes, sir.
Get an idea. Fantastic. So let's go to the next one.
Yes, sir.
Honey.
If v is the instantaneous velocity of the body dropped from top of a tower when it is located at height h, which of the following remains constant? Nice way of asking. Which remains constant? Is dropped from a height. So if it is dropped from a height, then I can write down v square is equal to 2gh, right? Or in other words, v square by 2 minus gh will be equal to 0. Will be equal to 0. Or gh by v square by 2 also should be fine. No? So this or this, they both mean the same. And hence, third one is the right option to this question. Very interesting, I say. Questions, in fact, I can do it very quickly because we had already revised. This revision is a very helpful tool. A motorboat covers the distance between two localities on a river in 6 hours downstream and 8 hours upstream. The speed of the boat is how many times that of the river? Very, very good question. Okay. Initially, when it is going downstream, what does it mean? Downstream means you are in the direction in which the river is flowing. It's called as downstream. It's called as downstream. Both the boat and the river are in the same direction. Now you have another one called as upstream. What does it mean? River is in this direction, but the boat is basically going up. So this is called upstream. Upstream. When these two are in the same direction, then the net velocity will be equal to VB plus VR. Here, velocity will be equal to VB minus VR. Minus VR. So let us look at the information then. 6 hours it takes in the downstream, obviously, because the distance, the velocity is more, so it takes lesser time. So 6 hours should be equal to D divided by VB plus VR. Then I have 8 is equal to D by VB minus VR. So I can write this as 8 by 6, therefore will be equal to VB plus VR by VB minus VR. Look at it, students. We want to know boat is how many times that of river, and therefore I want to find VB by VR. Question is, from this, how do you arrive at this? I hope you all know a method called compedendo dividendo. Okay, if you have an equation like this, then I can say VB by VR to be equal to 8 plus 6 by 8 minus 6. I can write it like this. Very quick way of doing it. So 14 divided by 2, therefore should be equal to 7. So VB should be equal to 7 times VR. So the answer therefore is third one for this case. Did you all appreciate the method of finding VB by VR quickly?
Yes, sir.
Okay, let's call it.
Okay, sir.
You all will know about it. It's only a recollection of those techniques and ideas, because now we are coming to solving MCQs more quickly. Which of the following statements is false? Look at it. Read. A body can have 0 velocity and still be accelerated. A body can have constant velocity and still have varying speed. A body can have a constant speed and still have a varying velocity, and the fourth one. So very interesting, very interesting. Body can have 0 velocity and still be accelerated. It's true, no? It's true, and therefore not false. Hence, remove this. A body can have constant velocity and still have varying speed. Can it? Can it really? This is impossible. If the velocity is constant, then it means that the magnitude of velocity also will be constant. Okay? And therefore, speed has to be constant. There is no other way. So this, in fact, is the false statement. False statement. And therefore, the one that we want. We want false statement. So second one. Moment you get a false statement like this, don't even bother about the other two. Okay, you may do that as an academic interest later on, but not in the examination. Forget about the other two. This is, you got the answer, proceed to the next question. Can we go on to the next question then?
Yes,
Yes, sir.
Yes, sir.
Okay, thank you.
Yes, sir.
Okay.
Okay, sir.
Keep reading this question, 7th one. I will see if there are some questions that are asked on the YouTube, because there is also, this is live streamed on YouTube, and I don't want to miss out those students. Okay, and therefore I also look at if there are some students who want some help watching the YouTube channel.
Yes, sir.
Yes, sir.
A particle is particle starting from rest moves along x-axis with its acceleration changing with time as shown in the graph. The speed of the particle at t equals 10 seconds is very, very nice. I have to find out what? Area under this curve. Very nice question. Area under this curve will give you the change in the velocity. Change in the velocity. So okay, not many questions on the YouTube, so let's not worry about it. So area under the curve is equal to change in velocity. So how do I find the area? How do I find that area? Very simple, isn't it, students? How do I find the area? Please look at it. Do it and tell me the answer. 7th question. Which answer is right?
B, sir.
Be B, isn't it?
B, sir, B.
Per second.
Yes, sir. B.
Okay.
20 meter per second.
Correct. So therefore, B is the second one is the right option. A rectangle ABCD has a length AB greater than breadth BC. A particle moves from A to B and B to C and finally C to D. Okay. If the distance it has traveled is 7 times the magnitude of the displacement, then the length of the rectangle is n times its breadth. The value of n is very, very interesting question, I would say. Okay, but try to understand what exactly it is saying. You have a rectangle, okay, where AB is greater than BC, and then you have D here. The particle moves from A to B, then B to C, and finally C to D. So it's here. It's here. The distance it has traveled is 7 times the magnitude of the displacement. If I call this as A and this as B, look what they have given you. They're giving you that the displacement is A and the distance that it has traveled is B plus A plus B. It should be 2B plus A. And the problem very clearly says the magnitude of the displacement. So D is 7 times, yes. So 2B plus A is equal to 7A, is equal to 7A. And therefore, what should be our answer? 2B should be equal to 6A, or they want the n times. So B therefore is equal to 3 times A. So what is the answer? Answer should be the second one. Answer should be second. Is it all right? Is it all right?
Sir.
Okay.
Yes, sir.
Let's do
Correct, sir.
9th question. A lift is coming from 8th floor and is just about to reach the 4th floor. Taking ground floor as the origin and positive direction upwards for all quantities, which of the following is correct? Which of the following is correct? Okay. X essentially is displacement, V is velocity, A is acceleration. What do you say about X? Oh, X is position, no? And positive direction upward. Okay. So X should be greater than 0, isn't it? Because this is your X equal to 0. 4th floor is here. So its position essentially is greater than 0. Correct. velocity it's coming down. So velocity is downward. So velocity is negative. A always is negative for me, I told you. And therefore my option therefore should be second one for this.
Option B.
Yes, sir. Option B.
Sir, right.
Option B is the right one.
Sir, it's option C, right, no, sir?
Why?
No.
A is greater than 0. Wrong, no?
Okay. Okay, sir. Okay, sir. Okay, sir. I didn't see that.
Okay. That's no problem. I see. That's no problem. Can we just do one more problem? I will take 2 more minutes of yours.
Sure.
Okay, sir.
Sure, sir. Sure,
Yes,
sir.
sir.
Remaining we'll try to do in the next class. That is tomorrow's class. I will be taking your tomorrow's class again. At what time?
9 o'clock.
9 o'clock, no, sir.
Yes.
9 o'clock.
Sir, 9 o'clock.
9
After
o'clock.
10 o'clock, maybe, sir. Do
Huh? Tomorrow is 9.
Yes, sir.
Yes, sir.
9, sir.
Class
Yes, sir.
starts.
Okay, sir.
Tomorrow we have physics. And
Okay,
then
sir.
11 o'clock
Okay, sir.
mathematics. Sri Hari Torgal sir. And I will be teaching physics. Sri Hari Torgal sir will be teaching mathematics. A wheel of radius 1 meter rolls forward half a revolution on the horizontal ground. The magnitude of the displacement of the point of the wheel initially in contact with the ground is. So if you have something like this here, it has traveled half a circle. So if it has rolled half a circle, remember it would roll like this. It is at this particular point. Here, what is the displacement? This displacement here will be equal to pi r. This distance is equal to pi r. This distance is pi r. Okay, and this will be equal to 2r. This will be equal to 2r. And therefore, I have to now get the magnitude of the displacement. Magnitude of the displacement is this. This is S. So magnitude of S will be equal to root of 4r square plus pi square r square. What is r? R is going to be 1 meter. And therefore displacement is 4 root of 4 plus pi square.
Option 3.
So it should be
option C.
correct. Option 3. Let me stop at this point. Okay. And then when we meet next time, that is tomorrow's class, I'll be starting with 2-dimensional motion. I'll see if I can do this
Thank you, sir.
once and then start off with 2-dimensional motion. All right. Come prepared for the class.
Yes, sir.
Thank you, sir. Great.
Notes of the first
Thank
year.
you, sir.
Thank you, sir.
Thank you, sir.
First year, note down all the important
Myself
ideas in
Vinay.
mind and come to the class. It will benefit a lot. With this, let me end today's class. But before that, how do you all feel? It is all right. Are you all able to manage the speed with which I'm going? What do you all feel?
Yes, sir.
Yes,
We can
sir.
follow you, sir.
Yes, sir.
Is all right?
Have a nice day.
Okay. How about the other subjects? You already had 2 chemistry classes, 1 maths class. How do you all feel in the classes?
Good, sir. Good.
Good, sir.
Good, sir.
Sir, will they not do biology?
Biology also will come, dear, but please wait. We will do it actually in the next cycle. We thought we'll at least get 2 classes of the subject. Otherwise, one of us should have got less class. So biology will start from next week. Okay? From 19th, we'll start biology. Definitely, yes.
Thank you, sir.
Thank
Thank
you so
you,
much.
Thank you.
You all have been wonderful
Thank you,
students.
sir.
So thanks a
So
lot.
will these classes be recorded on YouTube?
It's recorded on the YouTube and it is there. You can go to the
Will
same
it
link.
be saved,
This will be
sir?
recorded and it will be there. You don't have to even
What's
ask
the
me.
link,
It's
sir?
already there on the YouTube.
Sir,
Yes, sir. Thank you, sir.
complete physics will be done by you?
Mostly yes. Why you want a change of a teacher?
No, sir.
No, sir. No, sir.
No,
Sir,
sir.
yes, sir.
Sir, will you tell the link of the YouTube?
There will
So
be
that,
link of the YouTube. I'll send it. I'll send it. Okay.
It's on the screen itself.
Okay. I can basically copy it here.
Put it on chat.
Screen link. Okay. Maybe I'll just put it here. Okay. Just hold on. I'll just put it.
Okay, sir.
I'll just put it. I didn't share the screen. I should share the screen and then put this here. What up? Oh, it didn't really do it. Okay, let me see if I can show you the link itself. I don't know how to do that. I say.
Sir, can you provide any worksheet, sir?
I will. The same worksheet that I gave you, know, I'll be putting it on your this thing also. Yeah.
Thank you.
I'll be putting it. If someone has put the YouTube link on the chat, please copy it down. I have also put it now.
Yes, sir. I sent.
Yeah. Okay.
It's in the chat box, sir.
Yeah.
Sir, yes, sir. We got.
Thank you. Thank you.
Thank you.
Thank you,
Stop
sir. Your
the
name.
session now. Bye bye and see you all tomorrow morning.
Yes, sir. Bye, sir.
Sir.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Sir, one more doubt.
Yes, sir.